Hello and welcome to the third lesson in the first phase of our training. Without wasting much time, let's just look at the course outline for this particular lesson. So, in here, we're going to look at programming fundamentals, and the rest we're going to look at inputs, processing, and then outputs. From there, we go ahead and look at variables, how variables are declared, and how they are named, and how they are used. Proceed and look at data types where we have integers, floats, strings, characters, boolean, and all that. From there, we go ahead and look at basic operators where we have arithmetic, comparison, assignment, and then the logical operators. So let's look at the lesson objectives. So by the end of this lesson, learners will be able to, one, explain the concept of input, output, and process. And then two, explain what variables are, how to use variables, and how to name variables. Three, explain the various data types with examples. And then finally, the fourth objective is explain the basic operators such as arithmetic, comparison, assignment, and logical operators, all with examples. So that is the objectives of our lesson. So let's quickly dive right into it. Now we have identifier names. Identifier. When we say identifier, maybe something that identifies something or something, whatever, something like that. Yes. Names that identifies some things within others. So basically that is that. Now let's come into the world of programming. So identifiers are names of things such as variables, constants, and methods that appear in programs. Basically, identifiers here are the names of our variables, the names of our constants, and then the methods that we have in our programs. Basically, that is that. So all identifier names must obey the programming language rules for what? Identifiers. We have rules in programming languages how to name our variables, how to name our constants, and how to name our methods and all that. So to be able to name variable and use it successfully, constant and use it successfully, and methods and all that, you must obey, or they must obey or follow the programming language rules for identifiers, for naming them. Now, basically, we all know we have different types of programming languages, but the question is, are they all the same in terms of identifiers, naming of variables, and methods, and constant? Are they all the same? Let's look at that. What we are seeing here is it said these rules are different for every language, but the following, these rules we are talking about, each and every language has its syntax. For example, if I want to declare a variable in JavaScript, we use the var keyword. But for Python programming language, you just give the name of the variable and then you assign the value to it. So that is that. So you can see that the syntax here will be different. But what we are going to be looking at here in terms of how to name them and identify them in our programs cut across all other programming languages. These are general rules for all the languages. So let's take note of that. Now, what are these rules? The first one says an identifier name consists of letters, dig it, the underscore character, and then the dollar sign, and must begin with a letter, underscore, or the dollar sign. Now, in naming our variables, what we need to know is that we can name them with combining numbers and characters. But we have only two characters that can be added when naming our variables. That is, if you want to add them. It's not that they should be added. If you decide that, let me add dollar sign in this to differentiate it between this, you do that. It's allowed. If you say, okay, let me use underscore. Normally, we use underscore to bridge the gap, to close the space, because we don't leave a space when naming variables. Very soon we'll see examples of this. We don't leave a space. So to leave a space between example and there, you can introduce this underscore there. It's allowed. And we can equally start naming our variables with what? Underscore or dollar sign. Or we can equally end with it. It can come in the middle or wherever. But then, the identifier names can be any length, but should be what? Meaningful. When naming our variables or our identifiers, the names should be meaningful. For example, if you want to take a name and then the age from your users as input, you don't go saying, let's say, myself is equal to enter name. myself entering here is in a way it's not meaningful. So to be able to make it meaningful, you say what? Name or first name or full name is equal to then your full name. Age is equal to what? Then your age. So you see that any programmer that says this, you know that you are requesting for, you are taking input age and then name from your users, so they understand that. So that is what we mean by what it should be meaningful. Now that is that, and I'm repeating this again. Let's be very careful. Underscores and then the dollar sign are the only symbols that can be added when naming our variables or identifiers. Aside these two, you don't add anything. If you bring any inverted comma in naming your variable, it's wrong. If you introduce any other thing like a pipe or a slash or an ampersand or whatever, it's wrong. So we can only use this and that in addition to letters and then numbers. But note, don't start naming your variable with a number. It's not valid. We don't start naming a variable with a number. It's not valid. Example, one, name, something like that. It's not valid. Let's proceed and look at the examples. Say what? Identifiers can be made of only letters, digits, the underscore, and the dollar sign. No other symbols are permitted to form an identifier. That's what I've already stressed. When writing them, we can only use what I've already mentioned: the underscore, dollar sign, numbers, and then the what do you call it? Letters. You don't start with what? Numbers. We can start with dollar sign. You can start with any letter. You can start with the underscore, but we can't start with a number. But number is allowed to be used in the program or in naming a variable, but you can't start with it. Now let's look at some of the examples of legal or maybe acceptable identifier names. These include: first, you can name a variable like this. First, you can name it like this. Number is allowed. You can name it conversion is allowed. You can name it name. You see that here we use the camel case where maybe the first letter here is capital, and then the next one is small, and then capital and small in that way. And here to pay rate is allowed. Compute average is allowed. Camel case is used here as well. First name is allowed. Last name is allowed. Computer counter one is allowed, but you can't say one counter because it is starting with one. That one is not valid. You can equally say number one, but you can't say one number. Num2, F2 name is allowed. Dollar sign amount is allowed. You can all see. And then the underscore amount is allowed. Underscore amount is allowed. Underscore two place is allowed because there is underscore before the number, so it's allowed. First and then underscore name, just to close the gap. You don't leave space between them. So basically, these are the valid, acceptable identifiers. You can name your identifier combining the two symbols together with the numbers and letters. But then they should be meaningful, like we said. Let's proceed. Now, we have to try the following by ourselves. Say, indicate whether the following are valid or invalid names. That is naming our variable. My first program, is it valid? If it is valid, just tell me one, valid. Two, mix up. Is it valid? Just tell me valid. If it's not valid, tell me it's invalid. First one, if it's not valid, tell me it's invalid. Dollar sign programming lecture 2. Is it valid? If it's valid, tell me valid. If it's not valid, tell me invalid. So look through them and indicate. The one which is valid, say valid. The one which is not valid, you just say what's invalid. So basically, that is that. So you do that, and then you can pause the video here and do it before you proceed, because I have the solution just right after this slide. So please pause the video here, try this yourself. When you get to the next slide, there you look at the solution and then mark yourself. That's that. So there we go with the solution. So you have my first program here is valid. Mix up is invalid because this is a dash and not underscore, and this is not allowed in naming our variable. We have dollar sign programming lecture 2 is valid. It started with dollar sign is valid. We have 1 foot equals to 1 inches, which is invalid because you can tell it is starting with a number, which is not allowed. Mike's first attempt is invalid. Why? Because there is an apostrophe here, which is making it invalid. There shouldn't be any other symbol except dollar sign and then the underscore. But this has been introduced, so it's making it invalid. Update grade is invalid because there is a space here. So instead of leaving the space, close it and then maybe use camel case, update, and then grade the first letter for each word starting with what? Capital. And then, or you can decide to introduce underscore here just to close that gap. And then this one we have underscore student underscore number is also valid because it's started with underscore and there is no space here, and underscore has been used to close the space and all that, which is making it also valid. So that is that. You can then mark yourself and then you clap for yourself. If you score 7/7, bravo. If not, you know what to do. That is it. Now let's look at input. Now, what do we mean by input? We use this in our information processing cycle. We talk of input, processing, and output, and all that. So let's try to understand it very well here. Now, the input operation in a program transmit data from outside source to the program. Often, this data is typed at the computer keyboard by the person using the program. The program waits until the user types in something. Now we term raw data as what? Input. Whatever we enter from the computer from the keyboard terms as what? Input. Example, if there's a field that is prompting you to enter your name, at that moment where you begin entering your name, you are inputting something. If it is done, you input your name. It means the name has been what? Input. So basically that is that. So this action is referred to as what? Entering data from the keyboard. So whatever raw data we enter from the keyboard becomes what? An input. So that is why the keyboard is referred to as what? One of the input devices. So let's take note of that. Input means taking something into the computer. So and normally we do that using the keyboard mostly. If you want to enter name or whatever, we do that using the keyboard. So that is that. So we will use this statement when we are coming to start writing our pseudocode and then the flow chart, which we'll be looking at very soon. We'll be using this input keyword to allow the user to enter data from the keyboard. For example, if you want to write a pseudocode or a flow chart, I'm just using them for now. Very soon we'll understand what they are and see them and be able to design them by ourselves without any issue or without any stress as usual. So we will use what? A statement that begins with the word input to prompt the user to enter data from the keyboard. If you want to take a name from the user, we use this keyword and say input, then we say enter name. That tells the user that you are to type your name, and then we take it and then use it. We input it, we take it into the computer. The computer takes it and then use it. That is what we mean by our input. So take note. Wherever you see input in our pseudocode or flowchart, we are prompting the user what to give us something. Input age, maybe input length, maybe input width and all that, whichever we ask. If we want the user to enter it or to type it from the keyboard into the computer, we use this keyword to prompt the user to do that. The input, that is that. Now let's look at the examples here. Say, identify the input statement in the following statement. In the following statement 1, we have the right. This one displays something on the screen. So say right, enter the circle radius. Then input means enter what? The radius. Maybe you want to calculate the area or circumference of a circle. So you have to enter the radius. You know you need the radius as we've already talked about in a previous lesson. You need the radius. So you'll be prompted to what? Enter the radius. Then from there, we set circumference as 2 times pi times radius. And then we get the circumference here. Another prompt here says input. You have to enter 3 numbers, right? So this displays on the screen telling you to what? Input number 1. So with this, you'll be prompted to what? Enter first number, or that is number 1, number 2, and number 3. So the moment we see this, it is telling us to what? Enter something into the computer. So input number 1, it means enter number 1. After that, you enter number 2. After that, you enter number 3. Here as well, if you want to calculate the circumference or area of a circle, you need the radius, right? Good. So you say input radius, enter the radius. So this input keyword, we use it to prompt the user to enter something from the keyboard. Now, let's look at variables once again. See, when we write programs, most times we don't know the actual number of numbers that the user will enter while running or executing the program. Yes, naturally, it's like not only numbers. We talk of any data at all we take from the user. When we're writing our program, maybe we want to write a program, and then, okay, let me just take the lines here as my lines of codes I've written for a particular program. Let's say Mr. James or James is the CEO of our company, and then we are writing his profile or something here. And each of this line of code, there is a name James in it. There is a name James in it. So I'm just trying to explain to you one of the importance of what? variables, naming our variables or declaring our variables or using variables in our program. We can write programs syntax with what? James in all this. But the question is this: what if the lines of codes are more than this? Even with this, if we are asked to change, or maybe James travels, or James is no more the CEO of the company, and we are to, and the new CEO is in, and we are to edit this profile and then enter the name of the new CEO. We have to go visiting every line of code one by one, locating James and editing. That becomes boring, right? What if the lines of codes are even more than this? Because we can have billions and zillions lines of codes. What if each and every line of code in this has James in them? How sure are you that you can visit all these line of codes and then change the James, the previous CEO, to the current CEO name? So let's see how that is done. With a variable, the moment you declare a variable, say name or CEO name or the name of a CEO, which is equal to, and you enter what? James as the first CEO. Now, whenever we want to call James in here, we wouldn't call James anymore. We'll be calling the variable. Because whenever we call the variable, what we are looking for is a value inside the variable. Very soon we'll be seeing a variable and its value. That is its name and its value. We'll be seeing that. Whenever we call a variable, we are calling the name, the value inside the variable. Let me just give you an example of what I'm talking about before we proceed to that. We will even look at that in a few minutes. But then, let's just take our containers in our kitchen where we label them and then we put some items in them. Example, you have a container for keeping salt in it. You indicate it's salt. And you put salt in it. Another one, pepper. You indicate, write its name, pepper. And you put pepper inside it. Now, the labels on these containers are the identifiers. The content inside are the values. So the label we see salt is the name of the variable. The salt itself is what? The value of the variable. So whenever we call salt, we are looking at what is inside and not the label. So let's take note of that. But for us to know what is inside or to display what is inside is the label that guides us to see that. So basically that is that. So whenever we call the variable name, we are looking for the content inside. So when we set a variable name, let's say CEO name, and we say is equal to James. Whenever we are writing our codes or our syntax, whenever we want to maybe enter name of James, we wouldn't enter James' name directly, but we'll enter what the variable name, because James is stored in that. So whenever we run our program, James will display accurately. Now, with the declaration of the variable, when James is if James is no more and another CEO comes, you don't have to go around or going through all the line of code in changing all this. The only thing you have to do is just to come to a variable where you say CEO name is equal to James and change the James to what? The new CEO name, which can be maybe Michael. Just change that. So Michael will then store into what? The variable name what? CEO name. So whenever you run it, you see that Michael appears in all the lines of code. So you can see how important variables are for us. Very soon we'll see how they work in real coding. When we begin coding, we'll see how all these things work. So that is that. So when we write a program, we don't actually know what is going to happen. So it's advisable we declare variables for our names or whatever items we would like to be using in our program. So a computer program should always be written so that the user doesn't have to re-enter all the steps to get another result. Just as I've just stated. After writing it and then you declare a variable, you don't have to visit all line of code editing names again. You only come and edit the name here. Just change James to what? The new CEO, and then you get it up and running. Now, this is the definition of a variable. A variable is a quantity that can change value during execution. The moment we change the name from what? James to Michael and we run it, the variable changes, right? It changes when we run it during execution. So when you execute it, it knows that James is no longer stored in me, but rather it's Michael, and it displays Michael accurately for you. So that is how variables work. So whenever we need to refer to that data in a subsequent program's statement, we simply refer to its variable name. Exactly. Anytime we want to change the name of the CEO, we don't have to suffer going into the lines of codes doing whatever we want. All we just have to do is just to come here and then change the name here from what? Maybe Michael to another name. So basically, that is that. We'll see all this in real coding. So don't forget about that. Very soon we'll get there. Now, this is another typical example here. So technically, a variable is the name for a storage location. So the label on our salt is a name for a storage location. That is for a place for the salt inside the container. So the salt there tells you that inside the container we have what salt. Say, the computer's internal memory. So technically, a variable is the name for a storage location in the computer's internal memory, and the value of a variable is the content of that location. So the name is what is on top. Maybe this is the name, songs. So the value of the song inside here is what? 78. So whenever we call these songs, what we see is what? 78. Dollar price, that is the name. The value here is what? 77.22. Whenever we call this dollar price, what displays is what? The value. So that is that. Now let's look at, we've now seen input, how to take input from the users, where we use the input keyword and take input. Now after taking input, the input has to be processed. And then before we get the output right, it has to pass through some processes and all that to meet our requirement, what we need. So that brings us to what? Processing. So the processing operation in a program executes the statement that calls the program to do something. Whenever we use the word process, what we mean by process is that the data we've input into the computer, something should be done to it. So let's look at typical examples. Consider the statement: set sum is equal to what? var number 1 plus what? var number 2. What we are saying is that set sum is equal to, what we are saying is this: whenever we call for this var number 1, maybe it's a variable, right, which takes in a number, the first number, and this is another variable which takes in what? The second number. When we say set sum is equal to that, what we are saying is this: add the first number to the second number and store it in this sum. So at that moment, where the first number is inputted or is taken into the computer and is stored in this variable, the second number is taken and is stored here. At the moment where these two numbers are being summed or are being added, it's termed as what? Processing. So at the moment the addition is being done, it's termed as what? Processing. It means there is something in process. Something is happening to what? The data we've given to what? The computer. So basically, that is that. Whenever we say this, so we can use this in our writing, when writing pseudocode. So don't forget, when we say set this, what it means is that there is something has to be processed here. When we say set sum, we can say, let's assume we are finding a perimeter of a rectangle, once again. So at the initial stage, we have to take what? Input from the users, right? So we go back to our input keyword and say input, enter what? Length and width. We need the length and width to be able to calculate the perimeter. So after entering the length and width, it has to be processed to give us what? The perimeter. So how do we say that, or how do we set that? We say what? Set perimeter is equal to what? 2 times, or 2 into bracket, the sum of what? Length times the sum of what? Length and width. So at the moment where 2 is multiplied by the sum of what? Length and width, is termed as what? Processing. So basically, that is that. When something happens or something is happening to the data we've given or the input we've given to the computer, it means it is being processed. That is what I'm trying to say. Now let's look at output. The program's output is the data sent by the program to the screen, printer, or another destination such as a file. So an output here can be something that is displayed on your screen, or maybe you print it out from the computer, or maybe another file which you can maybe copy it from one location to another, maybe after doing whatever you want with it. So that is that. Now let's look at example here once again. When we talk of the perimeter of our what? Rectangle, we were talking of the perimeter of our rectangle where we took input from the users, right? And we took what? Length and width. That becomes the input stage. We came to the processing stage where we say set perimeter is equal to what? Multiply 2 by the sum of what? Length and width. So at that moment, that is processing. So after that, you have to display the perimeter, the result for the user to see. So that brings us to what? Output. After processing, the result must be displayed either on the screen for the user to see, or it should be printed out, or it should be stored in a particular file and be used at another location or whatever you want. So that is what? The output stage. So what? The program's output is data sent by program to the screen, printer, or another destination file. We will use the right statement to display message on the screen. So whenever we want to display something for the user to see, we say what? Write. So we can use write or we can use display. It means display this for the user to see. So for example, typical example once again, our perimeter. Let's go back. After taking the length and width as input, you process it, the user has to see something, right? For us to write our pseudocode or flowchart telling the user or telling the computer to show something for the user to see, we either use what? Write. So when the computer sees write or sees write, it means it understands that what we are saying is that display the results for the user to what? See. Show the output of what you have processed. So whenever you call the write or display, we are telling the computer to show the output of what it has what processed. So basically that is that. Now it's a statement like the following to display the value of what? A variable. Write circumference. So after finding the circumference of a circle, after taking what? The pi and then the radius as input, and you process it by multiplying 2 pi r square or maybe 2 pi r. After that, you would like to what? Display the results for the user to see. So in that case, you use the write keyword. You say write circumference. So the computer understand that. Display what? The circumference. It means display the results for the user to see. So basically, that is that. If you declare a variable, say first name is equal to input, enter your name. So, and you say write first name. Then when you declare this, it will display the name of the user. And not this, it will display the name because the name is stored inside the variable name here. We'll see more of that. Now let's look at we are still on programming fundamentals again. Now there are some words that we can use aside their intent, maybe their intended purposes or what they are used for. Let's take note of that. Those words are called the reserved words. The reserved words are also called keywords. Now, what are these reserved words? Reserved words cannot be redefined by the user within any program. That is, they cannot be used for anything other than their intended use. These reserved words are part of the syntax of what? A language. So with this, you can never use them aside their intended purposes. For example, a word variable like this, it's a reserved keyword for what? A computer. So I don't think we can use it when naming our variable. Another example is what? The print statement. A print statement is a function in Python programming. So when naming your variable, even if what you want the user to what enter is, so maybe you want the user to want to enter a printed document, and you think because of that, we say that the variables in naming variable, it should be meaningful, right? So you would want to what? Say print, enter printed document. Then when you use that print there, it's not valid. It's not allowed because it's a reserved keyword. It's a reserved word for what? A particular language, and you don't use it. So aside these reserved words, you can use any other word to name your identifiers or your methods or your variables or whatever. So that is what we mean by what? Reserved words. These reserved words are for what? The language. So you can use them. Example, while, for, if, else, print. All these are reserved words which you can use for any other purpose aside their what? Intended use. So what? A name constant is an identifier that represents a permanent value that never changes. Now, when we declare a variable or when we declare a name as a what? Constant, it means that name can never be changed again, or we wouldn't want anyone to change it. For that matter, we declare it as what? A constant. Whenever an object or a name or something is declared in a program as constant, what it means is that it shouldn't stand any change. It shouldn't be changed at all. It should be the way it is. Good. So the ways that specific words and symbols are used by each language is called syntax. The way we write program using each of the language or any of the language is called a syntax. Example in in Python programming language. If I want to say display something for the user to see, I use print statement. I'll write print or I'll type print and then into bracket, then inverted commas, then I'll write a statement. And when I run it, it should display the statement in the bracket and inside the inverted commas for me to see at the console. That is in Python programming. But when we come to what JavaScript, we have a statement we call console.log. Instead of print in in Python programming, in JavaScript, they use what? Console.log. It means display what is inside this bracket for me to see. So it also displays that. When we come to C++, to tell the computer to display something for the user to see, we say what? C out. C out. So C-O-U-T. C out. It means display this for the user to what? Also see. You can see that all these things are what? Different as far as each of the languages are concerned. Each and every language has its syntax. So whenever you see print something and then into brackets, and inside the bracket we have inverted commas, and inside the inverted comma we have a statement. Know that is Python syntax. Whenever you see console.log into bracket and then inside the bracket inverted commas and a statement, that is in JavaScript syntax. Whenever you see C out into bracket a statement telling that it means it's in C++. So you can see that the syntax are what? Different depending on what? The language. Now let's look at the operations on data. All programming languages support some form of arithmetic operation. The basic arithmetic operators include addition, subtraction, multiplication, division, exponentiation, and then modulus. So basically these are some of the operations that almost all the programming languages support. So let's look at them one after the other. Addition, which you and I know very well what it does. Subtraction, we also know. Multiplication, we also know. Division, we also know. Exponentiation, we also know that is the power. When we come to modulus, what the modulus does is that it's a 14 modulus what? 4. What we do here is we keep subtracting 4 from this 14 until we get to a point where we can subtract 4 again. And the remaining number becomes what? The result of the modulus. So that is that. You keep subtracting 4 from here. So you subtract the first 4, remaining something like 10. Subtract another 4, remaining 6. Subtract another 4, remaining 2. Which you can subtract 4 from 2 again. So you stop there and then 2 becomes the answer. So basically that is that. Now let's look at some of the things we need to take note of when writing our mathematical operations or formulas in programming. So to convert a temperature in degrees Fahrenheit to degrees Celsius, we use the following formula. 5 into bracket, C is equal to 5 into bracket, F minus 32 all over 9. Now, what we need to know is this. In programming, this is not possible. You can't write this. If you look at the keys on the keyboard, we don't even have a key to be able to write this particular line here, right? Even if we find a way to do this, the program will not recognize it because it's not accepted in programming. However, in a programming language, the following is written as follows. This same thing, this is how it should be written in a programming language. C is equal to 5 is multiplied by whatever is in the bracket, and then after that, all divides by what? 9. So when writing this in programming language, it should be like in this form or not in this form. Because in this form, the program will never accept it. Don't even try it. It will not work. So basically, that is that. Now let's look at hierarchy of operations. Here in our mathematics, where we teach student mathematics, we have a theory called the board math, where you say bracket of division, multiplication, addition, and subtraction, right? When we come to programming, we have similar issues to here like that, where we talk of hierarchy of operations. So the rules of arithmetic tells the order in which arithmetic operations is performed. Now this is shown below. First of all, when you have an operation which involves brackets, you have to multiply, you have exponentiation, you have whatever. To be able to tag the operation and get the results successfully, you have to perform the operation in the parentheses. We call it bracket, right? It's called parentheses. So you have to tackle what is in the parentheses. That is what is in the bracket first. After that, you look through the operation. Do we have exponentiation somewhere where a number is raised to the power another? If yes, after working with what is, or after performing the operation in the parentheses, you look at exponentiation. If there is 1, you go ahead and then execute it. Then from there, you go ahead and do what? Multiplication. If there is 1 in the operation, from there you go ahead and look at division. If there is division, after that you go ahead and look at modulus. If there is 1, then finally you go ahead and do additions and then subtractions. So if you follow this hierarchy of operation, you'll be able to get the result perfectly without any issue. If you just interchange them, example, you decide to go for exponentiation first before coming for what is in the parentheses, it may alter your answer. So let's take note of that. In programming, this is what we follow. They said there is a short phrase for it. We call it PEMDAS or something like that. PEMDAS, yes. Where we have performed the operation, what do you call it? parentheses, exponentiation, multiplication, division, and then modulos, and then addition, and then subtraction. So PEMDAS for short, just like board mass in general mathematics and all that. So that is that. Now, say, given the arithmetic operation, 6 plus all divided by 2 times 2 power 2. So work out this and see whether you're able to get this. After that, the same thing, but then the bracket has been the 2 times or 2 multiplied by 2 to the power 2 has been put into the bracket. You realize that the result should be different. Here, 6 plus 8 has been put into bracket. It's the same question, just that it has been changed based on the hierarchy of operation. So if you see the changes involved, try to solve them and make sure that you get all these things as your answers. So basically, that is that. Now let's look at comparison and then relational operation. So a condition is an expression that can be true or false. Yes, conditions or decisions we make in our programming, we normally use the Boolean, that is either true or false. Now, relational operators in programming evaluate to true or false. Exactly, that's what we are talking about. Our operators we use in our programming sometimes gives us the results as to whether what we are looking for is either true or is false. Now let's look at the various operators. We have the equality operators, that is for comparing two things, if they are equal and they are not equal. So basically that. In mathematics, where we use this equal sign, in programming we use it same as what? Equal, where we compare one item to the other. So if you want to say if first name equal Rashid, it means something should happen. It means you want to compare what is in the variable first name to Rashid. If what the user enters as the input is Rashid, then it means what is in the variable here is equal to the name Rashid. And for that matter, something should happen. If you want to say not equal to in mathematics, we use this, right? This is how it is written in programming. Not equal to, so we say x is not equal to y. As you can see, x is not equal to y. Now let's come to relational operators. So we have greater than, x is greater than y. Then we have less than, x is less than y. We have greater than or equal to, say, x is greater or equal to y. This is how it's written in math. This is how it's written in programming. So we have less or equal to. This is also how it's written in math, and this is how it's written in programming as well. So basically, that is that. Now let's look at the assignment operator. What is an assignment operator? An assignment statement designates a value for a variable. For example, if I want to take a name and compare to what I have in my variable, I want to compare a particular name to what the user enters. What I'll say is this: I'll declare a variable and take a name from a user. So I'll say input, enter a name. If the name is equal to so and so name, then something should happen. So whenever the user enters a name like James, the James is going to be stored in my variable name called what? First name. Whenever I check, so I want to check, I'll say if first name or the name stored in the variable is equal to the name I'm looking for, then something should happen. Are you getting it? But then before I do that, I will have to, after naming a variable, I will have to assign a value to the variable. So in assigning a value to the variable, we use the assignment operator. That is the one equal to. We have the two types of the equal sign. We have the one equal to, which is called the assignment operator, and we have the equal to the two, which is also called comparison operator. That one is used to compare two or more items or two items, but this one is used to assign a value to a variable. So if I say variable first name is equal to, then I will say so and so. What I'm saying is that take this name and store it inside the variable first name. That means I'm assigning the value to the variable. In that case, I use the single equal to. So that is that. Don't forget, the single equal to is an assignment operator, but the double is a comparison. It is used to compare two items. Example. Now let's look at this example. So example, sum is equal to 2. What I'm doing here is I'm assigning these two to the sum. So I use the assignment operator. Total amount is equal to cost price plus taxed amount. So in this total amount, the results here is going to be stored in this. So I'm assigning the result here to this. So whenever I call the total amount, I'll get this result. So basically, that is that. Now they are telling us more about the assignment operator. You say it's what? It assigns the resulting value of the expression on the right of the equal sign to the variable. Let me repeat. It assigns the resulting value of the expression on the right of the equals sign to the variable. Now, this is the right side of the variable, right? This is the right side of the equal to. This is the left side of the equal to. So it assigns what is here to here. It assigns what is at the right to the left. So that is what we are talking about here. So when anytime we call on sum, what we see here is what? 2. So sum is equal to 2, right? So we declare a variable called sum. And we are storing 2 inside it. So whenever we call sum, what displays is what? 2. So this is just the practical, the theory level. When we begin writing our pseudocode, you begin getting the concept. When we jump into flowchart, you get more of that. When we finally get to Python programming language, then the lights open for you to see everything clear. So that is how it's going to be. So we have to take our pupils through this step by step systematically for them to understand all the data types we have. Now let's look at the logical operations. So to test multiple conditions in decision making, we perform these tests in separate statements. Now at the point in time in our programs, we make a lot of decisions, right? We decide on things to do and what not to do. We try to compare things and check certain things. So to do that, we use operations we call the logical operators. Sometimes control statements require more complex conditions to determine a program's flow of control. Sometimes in our program, there are some, at a point in time, you have to make a lot of decisions to be able to allow the program to move from one level to another. That is the flow of control. So in doing all this, if there were not to be these logical operators, our programs would have been so horrible in a way that, in fact, I can just imagine how it would be. But thank God we have these logical operators. So what? Logical operators enable you to perform more complex conditions by combining simple conditions. Now, the logical operators are and, or, and not. Let me give you a typical example. If I want to compare two things, let me say I'm admitting student in this, maybe in my firm, or I'm admitting a student in my school. So I want to give the requirement. And the requirement is going to be, the person must be a male. The person must be above 18 years of age. If there is another requirement, I'll add. So for me to write a program to be able to what? Test the requirement and see whether the person qualifies for admission or not, I'll be using one of these logical or any of these logical operators to do that. For example, I will say that I'll write a program where the user enters the name. So you enter your name, so I'll take your name. Then you enter your gender. If you are male, you enter male, then I'll take. If you are a female, you enter female, then I'll take. Then after that, then you enter your age, then I'll take. So I would want to compare. So after this, I'll say, to compare, I use a statement called the if statement. We will see how it works. I'll say if gender equal male and age is greater or equal to 18, admission successful. So this is a simple program, right? So what I'm saying is this. I'm comparing the gender and then the age using what? The AND logical operator. So without this AND logical operator, how it would have been is something like, if gender is equal to male, then we terminate it there. Then we say display something. If age is greater or equal to, so it makes the whole program in a way, in a style, which you yourself you might not like. But with the availability of the logical operators or operations such as AND, or, and NOT, it makes it easier for us. If I want one of the requirements, either the person should be a male or above 18, then I use the OR operator to take care of that. So basically that is that. So these logical operators are very useful in programming. Very soon we begin writing our own lines of codes. We'll see how these things work. Now let's check the logical operations AND, or the AND logical operator. Let's see how it is used and how it works. It is used when we wish to ensure that two conditions are both true before we choose a certain part of the execution. For you to use the AND operator, what you are saying is this. The two requirement is a must. whenever we use the AND operator, the two requirements we need from our student is a must. That is, the student must be a male and the age must be what, greater or equal to 18. These two is a must. So, for example, gender. The gender must be equal female. This one we are using female here. Gender must be what, equal female, and age must be what, greater or equal to what, 18. So the program checks through this. They should make sure that this is true. The person must be a female. It's a compulsory. And then the age too must be what, either greater or equal to 18. So when you ask this is true and this is true, it means what, you'll be admitted. But if one of this is false, it means you'll not be admitted, because we are saying we are using the AND operator, which means both sides should be true. Let's look at the table here. Value 1, value 2. So this is the value 1, this is the value 2. So if the first value is false and the second value is false, it means that the result is false. The first value being false here means you are not a female, and then for that matter you should be a male, which has already disqualified you, so it's a false. The value here is also what? False, in the sense that maybe you are less than what? 18. So false, it means you are not qualified, so it's false. Program return false. Let's look at false and true. The first value here is false because you are not what? A female, and for that matter, you are a male, so you will not be admitted. And then the second one here is what? True, which means you are what? Either 18 or above 18. But still, you are not qualified because this one too must be true. You must be a male, a female as well. But in the case here, it's false because you are what? It's false because you are what? A female. So you are not qualified. I hope you are getting the concept here. The third one says true and false. True here means what? You are a female. So that one you have qualified for with that. But out of this place, it says false. False here means what? You are less than 18. So the statement here is false. So for that matter, you are not qualified. Although you are a female, but since you are less than 18, which is false here, you are not qualified. So true, false is false. Now the last one. True is true. True is true means what? The user is what? Actually a female, and then the age is what? Greater or equal to what? It's either you are 18 or you are above 18. And so this is true, and this is true, and for that matter, you are admitted. I hope I'm making sense here. Sometimes it looks, for the first time, those of us going through this for the first time, it looks confusing. Just as we all went through, but then as time goes on, you'll be able to become conversant with all this. It's very simple. It's very, very, very simple. So that is that. Let me try and see if I can go over again. Is that what? The first value is false, right? If the first value is false, second value is false, automatically you are not qualified. Here being false means it's not a female, but rather a male. So automatically it's false because you must be a female. Here also being false means that you are less than 18. So false, it should be false. So that is what we are talking about. Here, gender is equal to, here to the second one, we have true, means here actually you are a female. So you are qualified with that. But out of here is false. It means you are less than 18. So for that matter, false, true is false. You are not qualified. You must meet the both requirements. And the third one says false, which means you are not a female. You are either a female and then now your age is even greater or equal to 18. It means you are a male and your age is even less than. So it means both values are what? False. So it should be what? False. And then we have true, false. Here they are automatically true, which means you are a female. And then here is false. It means you are less than 18. So it's false. You are not qualified. But for the true means you have met the two requirements, and for that matter, true, you are qualified. So that is that. Now let's see the logical operation OR. Now we use when we wish to ensure that either or both of the two conditions are true before we choose a certain path of execution in our program. Now in here, we are not using the AND operator, but rather the OR operator. So for example, say gender equal female, right? Good. Or so this is a requirement once again. It's either you how will I say, you meet this requirement or you meet this one. Either of them that you meet, it means you are good to go. If you meet this and you didn't meet this, you are good to go. If you didn't meet this and you meet this, you are good to go. If you fail to meet both, it means you are not qualified. If you meet one of them, it means you are qualified. Now let's look at the table. False. False here means you are not a female but rather a male, so you are not qualified. Here too, false means you are less than 18, so you are not qualified. Now here is false. when we use or, it means either this or that. So any of them, we are good to go, right? We understand what or means. So even in English, that is what it means. It's either this or that. Any of them, I'm okay with that. So when we come to the second one, we say what? The first value says false, which means you are already a male here. You are not a female because it's false. Or, and then the age here is what? True, which means you are greater than what? 18. And for that matter, it's true because you are qualified. You have met one of the requirements. It's not compulsory that you should meet both. If you meet both, it's a plus. But then at least you should meet one of them. That is when we use the or operator. So when you come to the third one, say true. It means here you are a female. But here you are less than what? 18, which is false. Still you are qualified because you've met one of the requirements. And the last one, the natural one, true. It means both requirements are met, and for that matter, it should be true. So I pray you understand this as well. Now let's see the logical operation not. Let's see the logical operation not. The not logical, the logical operation not, also called the logical negation or logical complement operator, reverses the meaning of a condition. For example, actually, that is what this particular not operator does. Even in Python programming, you see how it is when you get there. We are going to write a simple game where we are going to combine all these things inside, and you understand it very well. When we try to compare to meet some certain requirement in our game and all that. So, example, value is equal to true. At the moment you say this, it's happening like that. But when you introduce not, the value becomes what? False. It negates the value. It changes the value from what? Negative to from what? Positive to what? Negative. That is what it does. It negates the value. That is what actually it does. So if the value is true and we add not to the value, it becomes false. If it is false and we add not to the value, it becomes true. That is how the not operator works. Now let's look at data types. One of the key components in our computing curriculum, where we are going to take the student through the various data types that we have. So the computer allocates a certain amount of space in its memory for data. So basically, whenever you declare a variable, the computer allocates memory for that particular variable, waiting for the type of data you are going to take from your users. But some data requires more space than the other, and some too require bigger space than the other. But before the computer knows the amount of space to leave for you, I have to tell it the type of data you are coming to store in there. So let's proceed. Say all data requires memory space, and types of data determines how much space is needed. That is what I'm saying. For the computer to be able to know the space to leave for you, you have to tell the computer the type of data you are taking from your users. For this reason, when we write a program, we must tell the computer what type of data we are dealing with. Exactly what I'm talking about. So when writing a program, you make provision of this. If the data you're going to take from the user is a string, it's a boolean, it's a float, it's an integer, it's a character, let the computer know and then prepare a memory location for that of your variable. So the program must define the data types of the variable being used. So when you declare a variable and you want to accept the data into that variable, you should what? Define the data type for it. If you are taking age, what data type is the age going to be? If you are taking name, what data type is the name going to be? If you are taking class, what data type is it going to be? So we should have all this in mind. Now let's look at the various data types we have. So the computer languages make use of three fundamental data types. We have the numeric data type, the character or the string or the alphanumeric data types, and we have the Boolean data types. So basically these are the three fundamental data types, but they are subdivided. So let's look at that. With the numeric data types, the numeric data can be further divided into two major types, where we have integers and then floating point numbers. So with the numbers, we have them in two forms. We have some as integers and we have some at what? Floating point numbers. The integers are the whole numbers, but the floating point numbers are those with the decimals. So the computer has made provision for all this. So that is that. We also have another data type called the character data. So character data can be further be divided into what? Single character and the single character data and string data. When we have a character, just one letter in an inverted commas, it makes it what? A character. It can be a character at the same time a string. But we have sequence of what? Characters, maybe a sentence, and all these sentences are in inverted commas. It becomes what? A string data type. So for example, if you want to take a name of a person like Kofi, Coffee is not a character, right? It's a combination of characters, Kofi. So you put it in inverted commas, it means it's a string. But if it is the initial and you decide to take only K, it becomes what? A character. So that is that. To be for the data type to be a character, it should be in inverted commas. For it to be a string, it should be in inverted commas. But the strings are a bit longer than the characters. With the strings, they can be a word, sentence, or whatever. So they must be in inverted commas. We'll see what the strings are. So take note of the following data types we have. We have the Boolean, we have the floats, we have the integers, we have the characters, we have the strings. So basically, these are the data types we have. Now let's look at Boolean data variables. So Boolean data variables can only have either true or false. Yes, if you want to set something to true or false, we use this. Normally, when writing games, we normally use this Boolean to terminate our games. For example, if you want to set end of the game or game over, we can set it from the initial state and say game over is equal to false. And as we play the game, there is something going on. Checking. At a point in time, we decide to jump out and set end of game is equal to true. So the moment that happens, the game comes to an end. It means the game has ended. So basically, these are some of the tips used in what? Designing and writing games. That is in programming. Basically, that is that. We will see it, so don't worry. Say what? Before you begin to use a variable, you must explain to the computer that you want a storage location set aside, and you want to give that location a name. So that is what we call variable declaration. In other words, you must declare a variable. For example, if I want to take an input from a user and say they should enter their name, I'll declare a variable called name. And I'll say it's equal to, then I'll prompt them to enter their name. So whatever they enter is going to be stored inside that name. And whenever I call that name, I see the value. That is the name the person enters. So any user at all that enters any name and I call the variable, I should see what the particular user enters, because each and every user has a different name in mind. So whichever they enter, I'll be able to see that type of name. So that is that. So different programming languages use different syntax to declare variables. Like I said, in JavaScript, they use var keyword to declare variables. In Python, we use what? Just the name of the variable, and then we assign the value to it, and we declare variable. These are some of the differences in syntax. Now we have the character data type as well. So character is any symbol that can be typed at the keyboard. Whatever we type from the keyboard becomes the character. This includes the letters of the alphabet, uppercase, and then lower cases. Numbers, punctuation marks, spaces, and some of the extra characters that a computer keyboard contains, such as the pipe, the various types of brackets. The various types of brackets, this is the curly bracket, or we call them the parentheses. The various types of brackets, that is the curly bracket or the square brackets. And we also have the parentheses as well, and other special characters like the dollar sign, the ampersand, the greater than sign, the less than sign, and so forth and so on. For example, this is an example of a character. Example, grade is equal to what? A. So having this only A in inverted commas means it's a character. It can be a string as well, because whatever is in between inverted commas is also what? A string. So this can be a character at the same time a string. So take note. A character can be a string at the same time a character, but a string can never be a character. I'll explain how we go forward. Now let's look at the string data type. Very good. So a string is a sequence of characters. A sequence of characters means more than one. You write them and combine them, being it a full name or maybe a first name or second name or whatever. That is combination of what? Sequence of characters. So when you combine sequence of characters to form a word and you put them in inverted commas, it becomes a string. I repeat. If it is one letter and it's in between, there is inverted commas covering it, it becomes either a character or a string, depending upon how you want to see it there. But if it is a sequence of characters, more than one character, and it has inverted commas over them, it becomes naturally a string. So that is that. Say what? In most programming languages, strings are enclosed in quotation marks like this. So whatever is written in between here, whatever is written in between here becomes what? A string. So basically that is that. Example, val is equal to enter the first number. So this is an example of a string. answer is equal to my name is Peter. So whatever you enter here becomes what? A string. So basically that is that. A single character is also considered to be a string, like I said. Although this is a character, it can also be considered as a string because it has inverted commas all over it. So a string may be void of any characters. It is called the null string or the empty string. Sometimes you can set a string as empty string without putting anything inside. So when that happens, it becomes the null string or the empty string. Sometimes we do that waiting for something to happen. We leave the string empty. We introduce the inverted commas and leave it empty without putting anything in between here because we are expecting something. So basically, that is that. When we get to the Python itself, we get to know. Now let's look at operation on strings. In many programming languages, we have a term we call concatenation. This concatenation takes two strings and joins them to produce a string result. The symbol that is often used to concatenate two strings is the plus sign. Please, let's take note of this word, concatenation. So whenever we use it, we understand what we are saying and then what we are using it for. Normally, you and I know very well that we use the plus sign if you want to sum two numbers. But in programming, we can use a plus sign to join two or more strings. In doing that, it is termed as what? Concatenation, where we use a plus sign to join variables together with strings, or join variables with variables, or join strings with variables, or the vice versa. It becomes concatenation. I repeat, when we use the plus sign to join two or more strings together, variables and strings together, strings and variables together, or characters, strings and variables together, it means we are concatenating. And for that matter, the process there is termed as what? Concatenation. Take note of that. Now let's look at examples. So for example, if string 1, if the first string is equal to part, so we are declaring this string 1 to be what? Part. So whenever we call string 1, what we see is what? Part. String 2 this is a variable, right? And we are assigning part to it. So this part is going to be stored inside here. So when we call string 1, we don't see string 1. We only see what? When we run this program, you don't see string 1. You only see the value inside it. And string 2 is also set to what? Time. So whenever we call string 2, what we see inside is what? Time and not string 2. So basically that. So for example, if string 1 is equal to part and string 2 is equal to time, then the statement is set new string is equal to string 1 plus string 2. How will this be displayed? Set new string. So we are now setting this. You can see that we are using a plus sign to what? Join two strings together. We are using the plus sign to join two strings what? Together. Or for now they are variables because strings are stored in them here. So we are using what? Plus sign to join variables together. But when we run it, whatever is in the variable is a string, and that is what we'll display. So when we use the plus sign to do this, what we are doing is we are concatenating. So for that matter, when the program is run, what displays is what? Part time. When the program is run, what displays is what? Part time. Because, let me take it over again. For example, I say if string 1 is equal to part, this is a variable called, there's a variable here called string 1, right? And we are assigning part to it. So whenever we call string 1, we see part. And string 2 is also a variable, and we are assigning time to it. Whenever we call string 2, we see time. So we are setting a new string, the output here. We want something to be processed here. We want this to be joined to this. So in doing that, using a plus sign means we are concatenating. That is what is termed as what? Concatenation. I want to display the results. The result is going to be displayed as what? Part time. Because we are concatenating the part which is in string 1 plus what? String 2, which is time. So it sounds what? Part time. So that is that. Like I said, and always I'll keep saying, this is just the theory. When we get to the practicals, you will see everything. Feely gadochi. You don't even have any issue there. So just relax. And then if there is any question, you can still ask for more clarification. Please ask questions so we clarify. We are all learning, right? We are learning, so we ask questions. Now let's observe this very well because we have some exercises we'll be doing by ourselves here as far as concatenation is concerned. So what is concatenation? Define it. Let me just here. So try defining it by yourself right now. That is when we try to join. It's a process of joining strings together, or variables and strings together, or strings and variables together using what? A plus sign. That is concatenation. Now, we are going to write a simple program and see how it's going to be displayed when you concatenate. Now, we are declaring items. So, anytime I want to declare variables in pseudocode, pseudocode is just like a false code, right? We use the keyword declare. We will get there very soon. That will be the next lesson. That is lesson 4. We'll see that. We use the keyword declare. Say declare item name, comma, text string, comma, and then item cost as strings. So whatever we are going to be storing in these variables is going to be a string. Like we said, before you declare a variable, let the computer know the data type you are going to be storing in the variable. So here we are telling the computer, hey computer, I'm declaring a variable item name. I'll be storing some name inside here. Another name I'll be storing here is what? Text string. I'll be storing another name in this variable name. And I'll be storing another thing in this item cost. And all what I'm going to be storing are all what? Strings. So I'm declaring all this as what? Strings, my dear computer. So understand that. You've told the computer that. So item name is equal to cashmere sweater. So whenever the computer sees this cashmere sweater, with this assignment operator, it takes the cashmere sweater and then put it inside here. So whenever you call the item name, you don't see anything, but rather you only see cashmere sweater. That is that. Now the second one, text string, and then will cost. So we are putting another string inside here. So whenever we call this text string, what we see inside is what? Will cost the dollar sign. So we see this displaying. Whenever we call this displays. The third one, item cost. With the item cost, we are setting it equal to what? 125. So this 125 is going to be stored inside here. So whenever we call on this item cost, this is what is going to be displayed. So we want to see the output. How is it going to be displayed on the screen? We want to concatenate the item name, text string, and then the item cost. So in concatenation, although we are using the variable's name, but when we run it, it is the values that will show. Although we are using the variable names, item name is a variable name here, text string is a variable name here, item cost is a variable name here. When we use the plus sign to concatenate it, when we run it, like I told you, anytime we call a variable, we don't see the variable. It only displays the value. So that is that. So when we run this program, it will display what? Cashmere sweater, then plus string, plus text string. What is inside text string? Will cost, plus what? Item cost. What is inside item cost? That is 125. So this is what to display. It will display as what? Cashmere sweater will cost 125 US dollars. Let me explain this again. I need you to understand this very well. What we are doing here is what we term as what? Concatenation. We are using plus sign to what? Join variables together here. We have declared variables here. I told you when we are declaring variables, if you want to use a variable in a computer, you have to assign it. Let the computer know that I'm declaring a variable. I want to store something inside it. But let the computer know the data type you are storing inside. In this case, the first variable name is item name. We are going to be storing the name of the item inside. So, my dear computer, anytime I'll be giving it a name, right? I'll be assigning something to this. So anytime I assign something to it and I call this, whatever I'll be assigning to it is what will display. I'm telling the computer again. There is another variable name I'll be calling text string, and I'll be assigning something to it too. So take note. Another thing is item cost, and I'll be assigning something to it too. And all what I'll be assigning to them are all strings. There is none of them that is an integer or float or boolean. So we leave it there like that. The computer is now aware. So now I'm going to do what I've told the computer I'll be doing. So I'm doing it here. Items name, computer. Now my item is what? Cashmere sweater. So take this cashmere sweater and put it inside. So anytime I call on this, you tell me this. The second one, the text string, computer, I'm putting will cost the dollar sign. So I'm putting all this inside here. Anytime I run the program and I call this, display this for me to see. Item cost equal to 125. My dear computer, I'm taking all this and I'm storing it inside here. Anytime I run it and I call the item cost, display this for me. So now we want to run it here. But before we run it and display, we'll have to process it. To process it, we concatenate it using the plus sign. So we call the item name, then plus, then we call the text string, then the plus, we call the item cost. So when we run its item name, it will display this first. So cashmere sweater is displayed. Then it will come. Test string, what is inside? Will cost. Then will cost will also display. Will cost dollars. Then it will come to the third line. What is there? Item cost, then it will display. So that will be the output. I pray you understand. You see it in coding itself. So that's that. Now, example 2. You can pause the video here. Or it's even the result, the answer is even displaying. So I don't think there's no need to even pause the video because the answer is already there. So what will be displayed on the screen when the following is executed? First, we are declaring a name here, right? We are declaring first name and then color. And both of them are going to be a string. We are telling the computer that we are declaring a variable here, first name, and then color. And both of them are going to be what? Strings. So my computer, take note of that. The next thing is, now the computer is now aware. So I'm telling the computer that I'll be assigning something to this. So I'm now going to do that. On my computer, the first name I'm going to assign is James. So please, my computer, take James and then store it inside here so that whenever I call this first name, you should tell me it's James. Secondly, my computer, I'm going to store this blue in this color variable. So whenever I call this color variable, display tell me the color inside, which is blue. So now I want to process something here, right? Don't forget, write means we're processing. So I want to process. So in processing, what I'm going to do is to concatenate. And to concatenate, I use the plus sign to join strings and variables together. So this is the first variable. When I run this variable, I should see what? James. And then the plus will not show because I'm just concatenating. So that one will not display. It will take off the plus sign and then it will concatenate this and display the results like this. So after running this program here, after using the first name plus the laughs, you see that I've put quotes, inverted commas over the laughs, right? That is because it's not a variable, it's a string on its own. So you don't do anything to it, just give it this. So it's a string. Then plus color. So I'm calling the color variable here as well. So when I run this program, what is going to happen is this. The computer goes into my program and then execute this and understand that I'm declaring the first name and then color as what? Strings. So it will then come to the second line here and check first name is equal to James. So it will take this and store here and run it, and it will display James for me. So now the program is running. I've just pressed the enter. Now the program is running. Let's see how it goes. The computer is now at this level checking. I've declared first name and then the color, right, as strings. So first name is equal to James. So the computer will check this. After that, it will come here. Okay, my user is saying that the first name is James. So I'll take this James and display. It will run and then it will display James for me. To come to the second line, he's saying color. What has he assigned to the color? Blue. Okay, it will run this and then it will display what? The blue color for me. But before it will run this, it has to check on this. After the first name, am I concatenating something or I'm concatenating the color at once? Now here I'm concatenating the laugh, which is also a string on its own. So after displaying this, it will come and check here and do what? Display this for me as well. Then after that, it will go and then check inside here and see what color have I stored in this color variable. That is blue. Then it will display this. So this first name plus laughs plus color will display James laughs blue. That is how it will display. So this process is termed as what? Concatenation. So I pray you understand. Please ask questions and then we clarify them for you. Example 3. What will be displayed on the screen when the following is executed? Here we are declaring, very good. Here we are taking two different data types. The first one is a string and then the second one is a float. The float is the decimals types. We talk of that. And then the integer is the whole number. So anytime you want to declare data types that are numbers, check out if it's about price of an item. Please take note of this statement of what I'm saying here. If you want to declare a variable for a number and tell the computer the data type, you have to analyze this issue here. Is it the age of someone? Age is a number, right? As they say. Football score is a number. And then a height of someone is a number. Length of something is a number. Width of something is a number. All that are numbers. Take note of that and know that at this point in time, the data type I'm taking here is going to either be a float or an integer, as long as it remains a number. In this case, I'm taking the height, and the height is a number. But what type of number? Because we talk of the numerical values being subdivided into two, where we have the floats and then the integers. The floats are the ones with what? Decimal places. So height like this can be a float, because at a point in time, there are some maybe decimals that can be attached to it. A price of something should be a float, or can be a float, because most of the times they can be decimal. Example, we have 3 cities, 50 pesos, so we have 3.50, right? There is a point there, so it should be what? A float. But age like this should be what? An integer, because it's just a whole number. It has no decimal point at any point in time. But then, to be at the safer side, to declare any number, you can just declare it as a float. If it comes, then you can do your own conversion. For example, when a number displays like this, 7.5, you know how to convert it, right? Maybe to one decimal place, it becomes 8, right? So that is that. So you have to take note of this. If the data type is a float, that is because if you declare it as a float, that is because you assume that it may be having some decimals. If you declare it as an integer, and it means that you are assuming that it has no any decimal place anywhere. It is going to be a whole number completely, no matter where it is and how it is declared. So that is it. So in our program here, we are declaring two data types. The first one is a string, because it's a name. A name is a sequence of what? Characters, more than one. So it's going to be a string, and it's going to be in inverted commas. So we are telling the computer, declare last name as what? A string, and declare height, since it's a number, as a float. So please, I pray you understand this. Now, the computer understands this now. Now it's running. Now, last name, we are assigning Cynthia to last name. So the computer check and take Cynthia and then store it here. Height, 7.5. It checks and then take this 7.5 and store it here. It says write last name plus is plus height plus meters tall. This meters tall is what? Inverted commas. So who can tell me what it is? It is a string. This is also what? In inverted commas. What it is a string. This is not in inverted commas because it's what? It's a variable. This is not in inverted commas because what? It's a variable, and these are the variables here. But when we run the variables, we don't see this, but we see the values. I've already stated this. So when we run this program, the computer displays this last name and then shows Cynthia. It displayed is because I'm concatenating the last name to what? The is, which is a string. It displays that. Then after that, it will just check the height for me, which is 7.5. Then plus height, then it will display 7.5. Plus, then it will display the meter store since it's also a string. So it will display like Cynthia is 7.5 meters tall. So basically, that is that. Now you have to try this by yourself. This is a typical concatenation story here. See, what will be displayed on the screen when the following is executed? The first one says, declare first name as string. Declare age as integer. I'm declaring age as integer because, who can tell me why? Because I assume that age is going to be a whole number. There's no decimal place in an age of someone. It's just a normal number. It can be 25, not 25 point whatever, or 75 point whatever. It's just a number on its own. So, and then we are storing John in last name. And then age is 75. So then the last name of the person is what? John, and then the age is 75. Now I'm writing this. How will this display? There is a man called plus last name. He is plus age plus years old. He likes the name plus last name, but he doesn't like to be plus age. How will this be displayed? So try this by yourself. Refer to the previous slides. 2-3 examples I've done using the concatenation. Then refer. Don't forget this is a string, and I'm concatenating a string to the age. So when I call this age, what should be displayed here? You know that. So I wouldn't want to talk much. So I think this will bring us to the end of this lesson. Try your hands on this. If there is any question, you go ahead and then you ask. Oh, sorry. So we are on. So let's go ahead and look at the integer data type. Very good. So now let's check. This is a typical example. So try this by yourself, and then you let us have your answers on the platform. So that is that. Let's go ahead. Now we have the integer data type as well. Now most programming languages allow at least 2 data types of numeric data to be used in programs. integers and floating point numbers. That was what I was making noise all this while. Integers and floating point numbers. Now let's understand them. Integer data consists of all the whole numbers, negative, 0, and positive numbers. Provided there is no point, something attached to it, it's an integer. So if you want to declare a variable and you want to tell the computer the data type you're using, ask yourself, the data type I'm taking here, although it's a number, at the point in time, will it give me a decimals? If you think so, then declare it as a float. But if it wouldn't give you a decimal, then declare it as what? An integer, because you know and you believe and you are sure that it's going to be a whole number, either a negative or 0 or positive whole number. So that is that. So the floating point numbers. So the floating point data consists of all numbers that include an integer part and a decimal part. So now, that's what I've just talked about. The floating point numbers, they have the decimal part, point something, 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 or whatever. So while the number 8 is an integer, the number 8.0 is considered as what? Float in programming. So this is a float and this is an integer. Take note of that. Something point becomes float. Something standing alone becomes what? An integer. A number standing alone becomes an integer. Then point something becomes a float in programming. So it has a decimal part. So that is why it is what? A float. Now, operation on integer data type. So the 6 arithmetic operators we can use for our integer data type are what? The plus. It means we can add them, we can subtract, we can multiply, we can add, we can divide, we can use modulos, we can use the exponentiation. All this may be used on calculation with integers. When working with numbers, these are the operators we can use. The result of adding, subtracting, exponentiation, multiplying, or taking the modulus of a pair of integers is another integer. What we are saying here is if you add two numbers, at the end of the day, you are getting an integer. You subtract two numbers, you are getting an integer. You multiply two numbers, you are getting an integer. Exponentiation, you are getting an integer, which means there wouldn't be a decimal point somewhere. 5 modulus 2, you are getting an integer. So basically, that is what you should take note of. So in working with things like this, and you want to declare or tell the computer the data type, you know that after all this operation, what I'll be getting is what? It's going to be what? An integer. So declare it as an integer at once before you even begin using it. So that is that. Now, the result of division operator on two integers is not normally an integer. Very good. So when dividing, at that point in time, normally it can be a float, it can also be an integer depending upon the numbers. So in that case, to be at the safer side, declare it as a float. For example, let's look at 5 divided by 2 is 2.5, right? Which is a float. Now, what of 6 divided by 2, which is 3? It's an integer. So sometimes you might not know what will happen in your division. So to be at the safer side, declare your results or whatever number it is as a float, and then you'll be good to go. Now, let's look at the declare statement. So when we declare variables in our pseudocode, we will use statement like the following. Declare number as integer, declare number as what? Float. Very soon we'll be getting to what? Pseudocode and then the flowchart. That will be the next topic. So when we get there, you would understand what I'm talking about. But let's try to understand these keywords here. Declare. We're going to use this in our pseudocode, right? So we say declare number as integer. If you want to take input from the user, what is that number? Is it an age of someone? If it's the age, it should be an integer. If it's a height, it should be a float, right? Because height has decimals. But age do not have decimals in them. So take note of that. So if you want to declare a variable, unlike the normal syntax where we have a way of declaring a variable, in pseudocode, which is a false code, which is just like a sketch. Like a sketch, I call pseudocode a false code, and then a flowchart, they are all false because they are like a sketch to a programmer, just like how an artisan sketches something and look at the sketch and do the original work. We talk of problem-solving techniques. When you identify the problem, you write the algorithm. It is the algorithm you are going to look at, then implement it in a programming language. So in writing the algorithm using either a pseudocode or a flowchart, we use this keyword to declare our variables. So declare whatever you want to declare as what. So sometimes our data types may include floats, strings, characters, or whatever. If you want to declare a character, if what you're going to take from the user is a name, you say declare name as what? A string, because it's a combination of characters. If you want to take from a user is what? A name of a country. It's going to be what? Guess. It's a string, because it's a combination of characters. If you want to take an input from a user, and its age is a number, right? And it's going to be what? A whole number. So declare age as what? An integer. If you want to take a number, something like a height from a user, you say declare height as what? A float, because height might have what? Decimal points or decimal places in it. So take note of that. We use this declare to declare our variables, and then we use this as whatever to what? Tell the data type we are declaring the variable for. Now, many programming languages also allow you to declare several variables in one statement, so long as all the variables in that statement have the same data type. Very good. Now, if I want to declare, maybe I want to take, like let's say 5 inputs for my users. 2 of them are going to be in form of numbers, or 3 of them are going to be maybe floats, and then 2 are going to be maybe strings, right? So those that are going to be as floats, I'll put them together and declare them at once using the comma to separate them. Those that are going to be strings, I'll also put them together and use the comma to separate them. For example, the first 2 I talk of, maybe the first 3 I'm talking about are going to be what? Integers. So, floats. So I'll be taking what? Something like, maybe the floating point numbers, price of an item, height, and then distance. So these ones, automatically, surely will be having some decimal places in this. Price of an item, height, and what? Distance. So I'll say declare price, comma, height, comma, distance as what? Integer. So you can see that 3 variables, and I'm declaring them straightforward, and I'm using comma to separate them. The second input I'll be taking is also what? A string. Maybe first name and then a country. So I'll say declare first name, comma, country as what? Strings, because the first name is going to be a name and it's a combination of characters. And then the country is also going to be a name of a country, it's a combination of a character. So it's also what? A string. So unlike saying declare first name as string, declare a country as string, different line, I can just combine them on one line and declare them. For example, declare number 1, number 2 as integer. Declare first name, last name, full name as string. Declare price, discount as float. So you know that price and discount rate automatically at a point in time there may be some decimal places in them or decimal point in them. So to be at the safer side, declare them as float. So we combine price and discount rate at a go and declare them as float. Even if there is another one that is going to be declared as a float, you can just add comma here and then add it, and then you declare them at a go. So basically, that is that. Now let's look at the Boolean data type. So a Boolean variable can only have a value of either true or false. A Boolean variable can only have a value of either true or false. When we talk of Boolean, this is propounded by a man called George Boole. So he propounded this. So most programming languages have a data type that allows for either true or false as the only option. Some names of this data type are Boolean. It can be written as this, Boolean, Boolean, or Bool. So, for example, declare flag as what? A Boolean. Maybe, I wouldn't use flag as an example here, although I've stated it here. In writing a game program, I'll say, I want to declare a variable called game over. And the game over, the data type I'll be taking for the game over is going to be what? A Boolean, which is either true or false. At the initial stage, I'll set the game over to be equal to what? False. Because when you begin playing the game, at that moment, it's not over yet until something happens. So as you play the game, I'm looping and checking. For the number of times I'll be giving you lives to take into consideration. If you have 3 lives, when you are caught the first time, life will be reduced to 2. When you are caught the second time, the lives will reduce to what? 1. When you are caught the third time, the lives go to 0. So when the lives go to 0, I'll say, if lives is equal to 0, set game over equal to true. So at that moment, the moment lives gets to 0, it set game over equal to true, and then it displays on the screen for you game over. So that ends the game. So this is a typical example I can use here. So that is where we use the Boolean. When we begin writing it, you see how it goes. So you have to try this by yourself. These are just some basic expressions. So following our what do you call it? I've forgotten of the term. Hierarchy of operations. Sorry, please. Our hierarchy of operations. So please just follow it and then you get me the answers to this, please. So if x is equal to 2 and y equal 3, give the value of each of the following expressions. So try working out this and then you get us the answers. So so this brings us to the end of this particular lesson. In fact, we've learned a lot. In summary, we talk of data types, and we all know the various data types we have. Where we have strings, which can be a single character in inverted commas or combination of characters like a name, country of someone, whatever it is, and then blah, blah, blah. Those are the strings. We also talk of Boolean, which can either be true or false. We also talk of floating point numbers, numbers that have decimal places. And we also talk of integers, the whole numbers. We also talk of how to name our variables. And we said those are the identifiers. And we said in naming our variables, we have only two symbols that we can use, the dollar sign and the underscore. We can combine numbers and letters to name our variables. And naming them should be meaningful, right? We talk of that. Good. They should be meaningful then. So we understood all this. And we also look at how to declare our variables using the declare keyword. And to declare a variable, you know the data type you're going to take from the user. So you let the computer know the data type so that it will allocate a memory size for it, because each and every data type has a size that it needs to be able to be stored in the computer. So you let the computer know of that. We talk of concatenation, where we join strings together using a plus sign, or we join strings and variables using a plus sign, or variables and strings, or vice versa using a plus sign. It is termed as what? Concatenation. And whenever we declare a variable, we assign a value to it. And when we call the variable name, we don't expect the name, but we expect to see the value inside. So when we run the program, example is if you say first name is equal to Fusaini, anytime you call on first name, what displays is what? Fusaini. So we've learned all that and then minimal. Please, you can go back over the slide, watch the video over and over. If there are some questions that are bothering you, go ahead and ask. Then by God's grace, I'll be able to also tackle them in one way or the other. Or maybe your colleagues who might be able to understand it in a better way can also be able to understand, maybe explain it for all of us to enjoy. We are all learning. We are all learners. Nobody is the master here. Yeah, we are all learning. So this is just the beginning. So we pray that you understand this. So this brings us to the end of this lesson. So until the next lesson, I say thank you very much for watching and bye for now.